All right, welcome to Unit 5. This is page 1 of Unit 5. We're going to be talking about exponential models, including they're going to have asymptotes in them and a whole bunch of other stuff going on. So this is the last unit of first semester, and we will be doing this pretty much through Thanksgiving up to before finals, then reviewing, and then finals near the end of December. All right, so on page 1, so we're going to talk about exponential models. So exponential can be increasing or decreasing. They always have the exponent is the variable. So a is some number. It's going to be bigger than 1. Where it's going to be like 3 to the x or 1/2 to the x and that sort of stuff. And the number that is there for the a is going to determine if it's growth or decay. So why can't a be 1? Because if a equaled 1, then you'd have 1 to some power, which would always be 1. 1 to anything is still 1, so it's going to be a constant. Never increases or decreases. All right, so when a is greater than 1, so if you have 3 to the x or 5 to the x or even 2 to the x, 1.5, doesn't matter, then this is an exponential growth. And if the absolute value is less than 1, so we are going to have exponential decay. So meaning, so an example would be like 1/2 to the x or 0.3 to the x, that sort of stuff. All right, so we're going to do the following without a calculator. So a little bit of review stuff here. 2 to the -2, negative exponents make the number, if it's over 1, it makes it go down to the bottom part of the fraction, or if it's in the bottom, it will go up. So we'd have 1 over 2 to the second, which is 1 over 4. So move the base. To make them positive, we move the base to the other part of the fraction. All right, 2 to the 1/2. Oh, sorry, let me give you a different example. So a little bit more complicated if you have negative exponents. So if you have x to the 3rd, y to the -3, and 2 to the -4th. The only thing you're going to move is the y, that will move to the bottom, and the 2 will move to the top. The x to the 3rd stays there because it's already positive. So this would come as x to the 3rd, would stay there. Y to the 3rd would move down, and 2 to the 4th would move up. So that would be 16x to the 3rd over y to the 3rd. Okay, so only the base, so only the number or variable that has the negative exponent moves. The other things stay where they are. All right, something we don't see quite often. Anything to a 1/2 power means square root. So it'd be square root of 2. The exponent is the same. So when the 1/2 exponent is the same as taking the square root. All right, so something like 9 to the 3/2 power. So this is 9. If I split it up, I take the top number out, so I have 3. And then that means that I also have to do the 1/2 power. So that you have a couple things going on. Or 9, you can do the, we'll take the 1/2, say the fraction out of it, and then you have the third power. So usually when you're doing these, it's usually easiest to make the root part first, because it makes the number smaller, and then when you deal with the whole exponent, it will make the number bigger again. So it's easier to make them smaller than bigger than trying to make them really big and then small. So the first thing, when you have the exponent like 3 halves, the first thing you want to do is take the square root and then cube the answer. So if you do the root first, the square root of 9 is 3, and then do the third power, which is 27. Now if you do it the other way around, you do 9 to the third power, that's fine. It's just going to give you like 81 times 3, so 273 maybe? No, yeah, 273 maybe, and then you got to do the cube root, which we don't know as well. So it just sometimes easier, the numbers are easier to deal with. Alright, so right away, so we talk about graphing these. Right away when you see this first one, a, f of x equals 2 to the x, I can tell this is going to be a growth because the whole number, the a value is a 2. Alright, so giving some of these, so just kind of making a table, 2 to the negative 2, 2 to the negative 1, oh my numbers moved off, 2 to the 0, sorry, this is negative 1 here, the 0 here, the 1 here, and 2. 2 to the 1 and 2 to the 2. Okay. Anything to a 0 power is automatically 1. 2 to the first, 2. 2 squared, 4. Remember, negative exponents, I flip it down so it's 1 over 2, so 1/2. The other one, 2 to the negative 2, is 1 over 4, because it's 1 over 2 squared. So you take these numbers as ordered pair. Negative 2, positive 1/4. Negative 2, positive 1/4. Then I have negative 1 and 1, positive 1/2. 0, 1. 1, 2, and 2, 4. Okay, you can see as the numbers are getting bigger, the x values are growing. As the x values are going from left to right, the graph is going up, so this is a growth model. Alright, this is an asymptote, so when I'm growing, I can never do anything, so I can never do 2 to some power that's going to give me a 0, so this is actually where an asymptote is. Okay, it goes through here, the y-axis at y equals 0. So the asymptote is at y equals 0 or the x-axis. So if you feel kind of comfortable on these, my grid messed up again before. I didn't see that before I printed it. Go ahead and make the table, make the graph, and just double check it. Alright, so I'm doing 1/2 to the negative 2, 1/2 to the negative 1, 1/2 to the 0, 1/2 to the 1, and 1/2 to the 2. 1/2, 1. This is going to flip it, so positive 2 and positive 4. Okay, so just let me show you real quick if you're not sure. Negative 2, the negative will flip the whole fraction because I'm doing everything to the negative 2, so it flips it to 2 over 1. So I square both of them, 2 squared and 1 squared is 4. Alright, so graph those points on there, negative 2 and 4. So the graph actually starts up higher, starts high and decreases. So in such a things as like when you get sick, when they test you like your maximum, maximum sickness, you have a lot of germs, and then when they start to go down quickly when you start feeling better. Okay, they talk about this a lot with radiation, where they talk about this with some forms of bacteria. They either growth or decay depending on how you are looking at them. Okay, again, when you do these, again, you have an asymptote here on the x-axis. So I don't care if you write x-axis or y equals 0. And asymptote, oh, cheesy Pete's. asymptote is at x-axis or y equals 0. And then this is a k-model because I am decreasing as I'm going to the right. When you're ready, flip over to page 2. Okay. So we're gonna do some more of these. I'm gonna have you do page 2 on the next day, so don't worry about that right now. We're gonna talk about, so we're gonna actually just take the graphs. So it's the same thing we started off at the beginning of the year. You're gonna take the graphs and you're gonna shift them right, left, up, and down. You're gonna reflect them and that sort of stuff. So we'll finish the notes for day 2 next time. For right now, on page 3, do the homework on page 3. Just page 3, so due on Monday. All right, we'll see you later. Bye.